Okay, thank you very much. So thank you for a really nice introduction. Good morning, everybody. It's a pleasure to meet you all here. Today, I would like to briefly introduce us, what we do, and how can artificial intelligence or intelligent resource planning or optimization help you to save your money, environment, and improve your services or processes. And in the end, Peter will share with you our successful stories. So we can start. So first of all, I would like to tell you a bit about us. Blindspot is a dynamic worldwide operating software company. We are based in Prague, in Czech Republic, and our mission is to be innovative partner for our clients. We absolutely understand and daily see the need to improve digital services and use of artificial intelligence. We were ranked to be the fast growing company in Central Europe due to Deloitte. And why we are here today, we are also part of the Adastra group, and where we cover up artificial intelligence expertise on global level. And what we do, we are delivering end-to-end software solution standing on principles of machine learning, artificial intelligence, and resource optimization for more than 7 years through industries like automotive, insurance, e-commerce, logistic, retail, and etc. We already delivered more than 140 successful AI projects all around the world, and we are really proud of that. Here you can see some of our clients, maybe some big names to mention, like Škoda Auto, Tuvzu, or DHL. And what is our expertise? What we can offer? If a customer has an accurate idea what his project or product should look like, we will develop it for him based on our expertise. We design tailored solutions, software solutions. We can provide a team of people. On the other hand, we already developed our own products. We have 9 ready-made products for business and operation optimization. These products are built on latest technologies in the field of artificial intelligence and machine learning, be it, for example, video analytic platform for safety and security monitoring, anomaly detection framework for fraud detection of frauds. And today, let's talk about optimization platform for workforce, routes, or planning in manufacturing, Optimus 4.0. Optimus 4.0 is a platform built on latest algorithms. It's very robust and can optimize a wide range of problems for companies in various industries. For example, from smart planning and scheduling of resources, people, tracks, routes, through planning of containers, loading, to optimization of complex processes in large operation inside production halls or outside of them. Based on our expertise from different industries and solving relatively the same business challenges for different clients, we have created 3 specific products about this platform, about Optimus. So we have OptiRoute, OptiPlan, and OptiFit. OptiRoute, as the name says, is optimization platform for optimization of routes. Easy. OptiPlan address effective shift planning, production or logistic in general, or optimization of logistic in general. And the last one, OptiFit, shows the optimization of fitting into box, onto container, or any other space. It's basically a really, really good Tetris application. And we have a video for you. This is a short video where I would like to introduce you what are we focusing on during optimization projects and what the result of the project might look like. We delivered this project for here called Opticon for Škoda Auto. And this project just become an IT project of the year. So we are proud. And as you saw on the video, it's somehow optimization of loading of containers. And today I have a Peter with me. Peter is expert of optimization projects, and I would like to ask him more about this project. So it's your turn.
Yeah, hello everyone. Thank you for joining us during this presentation. Thank you, Karolina, for the introduction. My name is Peter Zelenka. As mentioned, I play a role of head of delivery. So my responsibilities in Blindspot are making sure that we actually deliver something which is useful and brings value. I'm hoping that on this case, we've demonstrated we are capable of doing that. And this is just one single sample of optimization projects that we do. As you saw on the previous slides, Blindspot is not only about optimization, so it's not only about Optimus 4.0. We do many other AI-based projects, but for today we decided to focus on optimization. So with this particular one, with the Opticon, as Karolina mentioned, this is a very successful project for us. We are really proud that we were able to deliver this solution to Škoda Auto, because as you can read on the slide, the savings were just like enormous. So just within a first year, when this was in production, Škoda Auto was able to save more than 800,000 euros, plus obviously also nowadays very much observed CO2 emissions. So thanks to not shipping 302 containers in that year, they were able to contribute to the environment by saving 160 tons of CO2 emissions, which was also praised, and that was one of the reasons why Škoda Auto also started to work on this project. To give you a little understanding on of how the project actually worked and what was the previous state and how it ended, or what was the outcome technically, I'll try to explain a little bit. So Škoda Auto operates from Mladá Boleslav, Czech Republic, but not only. They have many places where they also manufacture cars, and they solve the problem that for distant places, distant markets, they ship the vehicles disassembled. So they ship them while they are still in parts, and basically they use these regular shipping containers to load the parts and ship them to the distant markets. The problem was that with the increasing complexity of the fleet that Škoda Auto is offering and all the models and different modifications, it became more and more uneasy for the forklift operators in the warehouse to actually figure out how to load the stack of pallets into the container. The forklift operators were very good actually. The way how they were working was admirable. Yet still, with this increasing complexity, it started to happen more often than not that some of the unpopular stacks, which were hard to place into any of the containers, were kind of left behind. So what we did for Škoda Auto was that we took our Optimus 4.0, in particular the OptiFit flavor of it, which is designed to solve these loading problems, and we connected it to Škoda Auto systems and built a front-end application for this solution that can be used in the warehouses. That was this tablet application you might have seen on the Choppy video. And this application now serves to the forklift operators and guides them how to load more into the containers. The increment or the improvement on the loading side doesn't seem significant just by like looking at it. It was on average 1 to 2 cubic meters that we loaded more into a container on average. So saved 1 cubic meter of empty void space, right? However, this 1 to 2 cubic meters globally resulted in these 840,000 euros saved during the first year. So that's Opticon. As mentioned, we are proud that we applied together jointly with Škoda Auto for IT Project of the Year, which we happened to won. So that makes us really proud that we were able to achieve that. In general, thank you, Carolina. The impact of the optimization. So if we step back a little bit, so this was one specific case, loading of containers. But in general, there are many areas and opportunities where optimization can yield significant savings, actually, or can make your business more let's say more efficient, such that with the existing resources you are able to fulfill increased demand. And to get you some data, some figures based on which you might start thinking, or whether this would be anyhow useful, or whether the savings would be like good enough for you. Here are some like four numbers. So in general, when talking planning, and this could be planning of manufacturing, planning of resources, planning of I don't know, routes for your fleet, the process of planning itself is much more efficient with this Optimus product in place. It's kind of self-explanatory. It's like automation. Majority of the planning, or the planning, is done automatically. You are still capable to do any manual changes if necessary, but the whole process is more or less one click of a button, and therefore the planning costs of the process itself dropped significantly by, on average, 80%. The time to actually create plan or create a strategy, create a new route, or recalculate the routes, time needed to put together a roster of employees into shifts also drops. So on average, again, this might vary, but on average we need just 1 minute to provide you with a plan which fulfills all your business requirements, business rules, internal procedures, but obviously also all like real world physical constraints, like regulatory requirements, etc. When we look just on transportation or logistic in particular, what we've seen on our projects which touched logistics, so whenever we optimize the routes or reshuffled how are different, let's say, suppliers managed by like different delivery routes, we always saw a drop around 20% on the cost of the logistic or transportation. And as far as the CO2 goes, it goes kind of along with that. So similarly, we have here 10%, again, on average, based on our experience on our projects. It's probably 10 to 50. It would be very proportional to saving of the transportation costs. So I've seen some questions dropping into the. You can't hear the sound. Okay, someone couldn't hear the sound. That would be unfortunate. Hopefully.
Yeah, maybe I, as a moderator, can jump in. Hopefully, it was only during the video, but but
all right,
if
okay,
you
okay, it was the
can't
video.
hear
Okay.
the sound, please let us know.
I would be like very sad if I was talking for 10 minutes and then realizing that actually I'm talking to the wall. Excellent. So I see some questions coming. What kind of quantity start optimization? Right. So I'm wondering, I might, if you don't mind, I'll address those questions shortly in 3 minutes. I just wanted to share with you 2 more cases such that you have another tangible thing to help you understand where the optimization can help. So this use case in particular we did for Tuvzu, which is a traditional German-based company. However, this case was done for their branch in China, where they are operating a service which allows you to inspect your goods manufactured in China while it's still like not shipped. So it's called so-called like a pre-shipment inspection. And Tuvzu operates several inspector hubs in different China cities. And the task at hand was every day there are approximately 100 of inspections that need to be done. Tuvzu has 200 to 300 of inspectors spread across China cities. And the task at hand was how to build teams of inspectors and send them to inspections. The most tricky part on this use case was to actually understand and model all the different rules and requirements that had to be followed, how the team should be assembled, what are the demands on the team members, whether the team members can actually inspect goods of this and that client, etc. The state 0 was we were using an Excel. Actually, 6 to 12 people were screen sharing screenshots or screen sharing the Excel itself, trying to figure out how this will work. End result was a web application which is connected to their actually 2 of back office systems where the inspections are kept and where they are coming from the field. So it's pulled to the system, automatically scheduled for the upcoming days, following all the rules and regulations that they need to follow. So that's like rostering combined also with optimization, in a sense that we obviously try to reduce the time traveled. So inspectors are most useful when they can do inspection, when they travel half of the day to the place where the inspection should take place, not that much. So that's another case. And Carolina, if I may ask you one last case, and that's the logistics. So the most, like probably most understandable. This is kind of like a blended slide of 2 case studies. The one was for actually suggesting better routes. So imagine that you have a fast food chain with many locations where you deliver your baguettes or whatever, and you need to ensure that you hit the delivery windows, you make sure that VIP clients are never left behind, your mileage is as low as possible, things like that. So for the client, again, status quo was printed out map and colorful pencils. End result was an application where you can drag and drop a new delivery place on a map and let the system recalculate the new routes setting, such that your delivery people know what are the points of interest, so to say, on the routes that they are running. And the other part that was blended was an inbound logistic case where you had many suppliers, and your goal was to stop by at the suppliers, pick the parts you needed for your manufacturing and deliver those parts into the main manufacturing place. So it was a problem in literature known as milk runs. The tricky bit here was not just the milk runs problem, but also being able, again, to model all the constraints that need to be followed. Here in this case, in particular, it was a very much constrained way how the parts can be loaded on the cargo space of the vehicles. So we had to be able to also reflect the weight distribution such that the axis of the vehicles are evenly, like the weight is distributed evenly on the axis of the vehicle. The cargo is placed in a way it doesn't fall at each other when the vehicle is running, etc. So another case, just to give you an idea of what kind of situations you can solve with the Optimus 4.0 and the dedicated products for particular situations. That being said, I can jump into the Q&A. Martin, you wanted to say something?
Yeah, let me just raise the questions. I just was really curious about the questions, and but I didn't want to stop you because the story that you talked about was really interesting. We have here some questions, so let's go one by one. I will click on them so everyone can see it and you can answer. So basically, what is the best way to start with optimization? Process optimization or operations first? Like, what is your suggestion?
It's a very generic and very hard question to answer generically, right? So I think there is no no best place to start. I think what I sense is the most crucial part with optimization is actually the good understanding of all the business specifics, the domain specifics, all the considerations that you do in your head without thinking. But if you want to automate, if you want to use a dedicated system, you have to tell the system that, okay, I'm also considering that this guy goes to the dentist in the afternoon while I'm planning, etc. So, and from that perspective, I think the best way where to start is to start at place where there is a keen interest of getting out of the laborious planning, and there is someone who is really a champion of the optimization and champion of the automatization, such that you have a partner who is really very keen to get this done and will share with you basically everything he considers or she considers while doing the planning. So I think it's probably finding a place where the end user, the key persona will be using this, is on board and is really like pushing this forward. So that's the right place to start, regardless whether this is process or whether this is operation.
All right, Peter, thank you very much for that. Let's jump to a few more questions. We still have you here.
Sure.
So let's go to another one. How do you take care of traffic? Is it updated in real time?
Well, very good question. We do not none of our implementations of Optimus was in the area where we would require live information about the traffic, which is maybe a little bit surprising, and I'm thankful for that question. Majority of these installations are not live planning. It's more like planning for another day, another week, another month, another year, but not for another hour. Not that it wouldn't be possible, but we never installed any at any client, we never installed this in a way that we would need live traffic information. That being said, for the China use case, for instance, when the inspectors are being sent to different locations, we were using Google and Baidu, that's the China version of transport information or traffic information provider, to estimate the time needed to get to a place where the inspection should take place. But that was done, 1 day in advance, and it was some, statistic representation. So we don't use live information for traffic.
All right, we still have a few minutes, so maybe let's jump to another question from Roman. How do you deal with the complexity of the use case? Do you run simulations in analytics to get better results at the end? Roman Żabka.
Very good question. Again, we have good listeners. I'm excited about that. The complexity of the use case is really something which we deal with basically at any installation. And I can't say we do simulations like in the let's say simulation science perspective. What we do, on the other hand, is at the very beginning, we talk to the subject matter experts, the domain experts who deal with the planning at client. Then we model the constraints and actually the planning problem itself in Optimus. So we teach in quotation mark. We like configure Optimus to understand the problem and the data that we will feed to Optimus. The data being, I don't know, we have this many vehicles and we have this many clients and this delivery windows, etc. Do your math and come up with the optimal routes. So we teach Optimus to understand a problem like this. And then we iterate a little bit to figure out what are the considerations that were not mentioned, not identified, and B, to properly fine-tune the true optimization criteria that they want to achieve. So that it's always like trade-off between, strict optimization just on the mileage or, optimization that also takes care of the time of the people, things like that. And basically we work together to fine-tune these weights, if I may, and come up with something which produces a plan which blows the people away.
Yeah. Carolina, Peter, thank you very much for the presentation. I believe that it was so exciting also for the others, not just for me. And from the questions, we can see that this topic is really relevant. Yeah.